Yesterday, we have discussed about uniform distribution with some numerical example. After that, we have studied Bernoulli distribution and we derived mean and variance of Bernoulli distribution. I will recall little bit about Bernoulli distribution and then we'll proceed for a binomial distribution, because binomial distribution is the generalization of Bernoulli distribution. Bernoulli distribution basically based on the Bernoulli trials. That means random experiment which has two possible outcomes classified as success and failure. So we perform such experiment only once, so it has two possible outcomes and the corresponding experiment will be labeled as Bernoulli trials. For Bernoulli trial, you can define probability mass function as Px equal P raised to x Q raised to 1 minus x, where x takes values either 0 or 1. In this case, P stand for chance of getting a success and Q stand for chance of getting a failure. Now we will proceed for binomial distribution. Then I will tell you what is the relation between Bernoulli distribution and binomial distribution. Firstly, we will try to see how to define a binomial distribution. A discrete random variable capital X is said to follow binomial distribution if its PMF is given by. So yesterday I told you this is the standard form of definition for any distribution. The most important part is to remember this square bracket. You have to remember this perfectly without any mistake. So what is the binomial formula? Px equal, it should be small x because probability defined at each value. So when you think about each value, it is a small x. So P bracket small x equal n choose x, this is the combination, P raised to x, Q raised to n minus x. Semicolon, x taking value 0, 1, 2 up to small n, where in this function P is a constant lies between strictly 0 and 1, not equal 0, not equal to 1. Q is a function of P defined as 1 minus P. Just like Bernoulli, P is a chance of getting a success and Q is a chance of getting a failure. The same concept is continued for binomial. If your x is not coming from this range, function will be 0 otherwise. Now in this formula, in this function, what is x stand as a random variable? So now it is capital equal to number of success in n trials. What is P stand? Just now I told P is probability of getting a success in one trial. This is important. What is Q? Probability of getting a failure in one trial. So at this stage, your definition is complete. So in exam, if somebody asks, define a binomial distribution, you have to start from this point, write a function, explain each and every notation involved in the function, then your definition will be complete. If you want to denote this function by notation, you write x capital as a random variable follows binomial bracket n comma p, where small n and small p are known as a parameters. Now, what is the concept of parameters? Parameter is nothing but unknown constant given in the function. So this function depend on two unknown constants. One is small n and other is p. If you have a knowledge of p, you can develop q. So this function depends on two values. One is small n and other is small p. So these two values, these two constants are known as a parameters. Now on this function, we put certain remarks. Remark, binomial distribution is based on individual terms of binomial theorem. You can recall your mathematics knowledge. You know the expansion of a plus b whole bracket n, provided n is a positive integer. So we can write an expansion of this bracket, summation x start from 0 to n choose x, it is a combination, a raised to n minus x, b raised to x. You can make a reverse also. You can say a raised to x, b raised to n minus x. Doesn't matter, the expression will remain same. So this is nothing but your binomial theorem. So if I take only this much as a general term of expansion, this is nothing but your binomial distribution. N choose x, p raised to x, q raised to n minus x. That means in place of a, write p, b as a q. So p plus q raised to n is written like this without summation if you want to define the particular term of binomial distribution. So that is one remark. Now, what is the real life situation to study binomial distribution? Just like yesterday I told you, Bernoulli distribution is applicable in the real life if the random experiment under study has two possible outcomes. In the same guideline, you have a situation of binomial distribution. Let us see when you apply binomial distribution in the real life. We use binomial distribution in real life under following conditions, under following situations. Condition number one, the experiment, it should be EXPT, short form of experiment. The experiment should have exactly two possible outcomes in every trial. That means if you want to apply binomial distribution, your experiment should be Bernoulli trial. That is why at the beginning I said binomial distribution is a generalization of Bernoulli. Condition 1 says experiment should be of type Bernoulli. That means every trial, every repetition should possess two possible outcomes. What is condition number 2 says? The chance, probability of getting a success denoted by small p remain constant for all subsequent trials. That is condition 2. Condition 3, such experiment should be repeated at least 2 times. If you repeat only 1 time, that is a Bernoulli distribution. If you repeat more than 2 or minimum 2 times, Bernoulli distribution shifted to the binomial distribution. That is why you have a correlation between Bernoulli distribution and binomial distribution. What are the examples? Number one, tossing a coin 12 times. Recall yesterday's example of Bernoulli. I said tossing a coin once. So if you toss only one time, that is a Bernoulli distribution. And if you toss more than one time, it converts to the binomial distribution. So repetition of experiment 2 times or more than 2 times, that is nothing but a binomial distribution. Here 12 is a particular value. You can put any number, any positive finite number. Example B, result of examinations for 15 students and so on. Yesterday I said result of examination for 1 student. Now here I am saying 15 students. So if you repeat your experiment 2 times or more than 2 times, then such experiment studied by binomial distribution. You have third situation, the binomial distribution can be used to study population by using a sample by simple random sampling with replacement. In your paper 1, there are 2 types of sampling methods, simple random sampling with replacement and simple random sampling without replacement. So if you select a sample from the finite population using SRSWR, then you can use binomial distribution. So these are the 3 situations where you can use binomial distribution in the real life. What I want to say, if you are studying an experiment which is random and having exactly 2 outcomes at every trial, and if such experiment repeated more than 2 times, then you can always think to analyze that experiment with the help of binomial distribution. Let us see now how to derive mean of binomial, variance of binomial. Mean of binomial distribution equal, as per definition, mean equal expected value of x written as summation x px, x takes value 0 to n, x multiply px, that is n choose x, p raised to x, q raised to n minus x. Now you can see comparatively these 2 steps. Where is the change you observe? I simplified first 2 terms, x multiply ncx. You can do this on your rough page, that if you apply the combination formula, writing ncx as factorial n divided by factorial x multiply n minus x factorial, simplify x factorial with x, and the rest part is adjusted, so you get this simplification. So what is your homework? You have to prove x multiply ncx equal n time n minus 1 choose x minus 1. This is the homework. Rest part is same. Now in this step, n is a constant without x, so it remains constant for all x. So we took it out of the summation. So next step, x is 1 to n, n minus 1, choose x minus 1, p raised to x, q raised to n minus x. This is the simplification. Now here, we use a binomial result, binomial theorem, which I stated in remark. A plus b to the power n is summation x0 to n ncx a raised to x b raised to n minus x. This is a binomial theorem. Let us compare binomial theorem with your step. Can you apply this directly? Answer is not. What binomial theorem characteristics? Under combination ncx, so x is a power of one of the term. And what is the power of another constant? It is subtraction, this minus this. Let us look your combination. It is n minus 1, choose x minus 1. So if you want to apply this result, power of p should be x minus 1 and power of q should be this minus this, and that is coming n minus x. So no hurdle for q raised to n minus x. It satisfies this condition. But a raised to x should be x. Here it should be x minus 1. So we make adjustment before applying binomial result. And that adjustment is small n as it is. I multiply p here and I change p raised to x as p raised to x minus 1. So this minus 1 and this p raised to 1 get cancelled. So this step is very important in the derivation. So you should remember this nicely. Now you can see this exactly satisfies characteristics of your binomial theorem. Again I repeat, a plus b to the power n is written as summation x0 to n ncx a raised to x b raised to n minus x. That means if you want to apply binomial result to your step, power of a should be x, power of b is n minus x. And that's why we change p raised to x to the p raised to x minus 1. And what is extra? Extra is p raised to minus 1. So this nullified by multiplying p outside. Now, according to this theorem, the answer of this complete yellow mark is P plus Q. A is P, B is Q. P plus Q whole bracket n minus 1, here it is n. But what is P plus Q? By definition, P plus Q always 1. This is wrong. It is 1 because Q is 1 minus P. So quite natural, P plus Q equal to 1. 1 to the power anything is 1, so this quantity cancel. So what is your mean of binomial? Answer is coming NP. Let us go back in yesterday's class. In case of Bernoulli, we derive the mean. And how much mean we got? For Bernoulli, it is P. That means if I put n equal to 1, n is how many times you repeat your experiment. That means you repeat Bernoulli trial how many times? If you repeat only one time, so n is 1, so mean become p, and that p is for Bernoulli. And that is why I said from the beginning, today's topic is a generalization of yesterday's Bernoulli distribution. So Bernoulli distribution has mean p and binomial distribution has mean n into p, where n stand for number of trials. For example, 1, you toss a coin 12 times, so n is 12. You are studying the result of examination for 15 students, so you repeat your Bernoulli trials 15 times, so small n is 15, and so on. That is why mean is coming n into p.